It is now time for our first keynote session where we will have the privilege of hearing from a very distinguished professional, Ms. Kshama Jain Madam. She is Managing Director, KEHEMS Technologies and also IPP ISRA Indore Chapter. She has been the president of ISRA Indore Chapter 2022-23, treasurer and CWC member. She has received her Bachelor of Science degree in Economics from University of Essex, Colchester, United Kingdom in 2001 and honorary postgraduate diploma in Business Administration from IIM Bangalore. She is the winner of prestigious Global Women Business Award and also Woman Entrepreneur of Madhya Pradesh. She has been handling and making the presence of the brand KEHEMS felt across the nation despite it having all major global MNCs as competition. She is highly respected within the global fraternity and is also a visionary leader who has not only navigated the organization through the global crisis of COVID but has also set a benchmark in the industry. Now, I request Madam to please kindly come on stage.
Good morning again, everyone. As you can see that I will talk about chillers, basics to advanced. So we are just seeing what are chillers, what are the types of chillers available in the industry, how they are applied in the industry, and what is kind of futuristic approach to chillers in the industry. So basically, what is a chiller? Can anybody in the group answer this question? I'm sure you must have done RAC in some of your semesters. Anyone? Okay, we have a shy crowd here today. Good. So a chiller is a machine that removes heat from liquid coolant via vapor compression, absorption refrigeration, and or absorption refrigeration cycles. Okay, so what we are talking today is that there are basically two refrigeration cycles. One is compression cycle and other is absorption cycle. How different they are to each other, we will learn in slides forward coming to each other. So basically we know that there are different types of chillers. It is important for us to understand what their name means, okay? So we'll learn about them in upcoming slides. The first way to categorize a chiller is by defining whether it is vapor compression or vapor absorption cycle. So what is a vapor absorption cycle? Vapor absorption refrigeration system includes all the process of vapor compression such as compression, condensation, expansion and evaporation. However, the only different thing which you can see here is a absorber and a generator, which is different in vapor absorption cycle. So compression takes place in these two areas, absorption and generation. In vapor compression, what is happening is that the refrigerant circulates through system. It is alternatively compressed, expanded, and is changing its state from liquid to vapor. And this is how energy is generated. Basically, we have four main components in vapor compression cycle, which is a compressor, an evaporator, a condenser, and an expansion valve. So here we see the two types of compression cycles, a heating cycle and a cooling cycle. Heating cycle is completely reverse of a cooling cycle. So when we talk about a cooling cycle, what is happening is that vapor is getting compressed and the compressed vapor is coming to the condenser. Through expansion valve, it again goes to the evaporator and goes back to the compressor. This is the cycle which is operating. Here we get the cold water or cold air through evaporator. In the heating cycle, it is completely opposite. You get heated air or heated water from the condenser. And as a byproduct, you get cold air or cold water from the evaporator. So these are two types of images which you can see between vapor compression and vapor absorption. Here you are seeing that the condenser is condensing the vapor through the filter dryer and expansion valve. It is going to the evaporator. From evaporator, it is getting evaporated, and the evaporated gas is going to the compressor to get compressed, and then it again goes to the condenser. Now these condensers can be of two types. It can be shell and tube, or it can be coil types, which we will also learn in the upcoming slides. In vapor absorption, you see that the compressor is missing. So you have a generator and an absorber. Again, all other components keeping the same. So what is the major difference between an absorption and a compression cycle? The major difference of the two systems is the method of suction and compression of the refrigerant in the refrigeration cycle. Basically, in vapor compression system, the compressor sucks the refrigerant from the evaporator and compresses it under the high pressure. And in vapor absorption system, the process of suction and compression is carried out by two different devices called absorbers and generators. So we can define the chillers into two different divisions. One is vapor compression chiller, which has 4 different categories of compressors being used: reciprocating, centrifugal, screw and scroll. And vapor absorption, which has again 4 different categories. First is direct feed, then lithium bromide is actually the media of chilling in vapor absorption chiller, single effect, single stage, or double effect and double stage. And broadly, we can distinguish the chillers between water-cooled condensers and evaporative condensers. So we come to applications now. Chillers can be defined into broadly 2 parts. One is an air-cooled chiller, and second is the water-cooled chiller. You see, in air-cooled chiller, the heat is getting dissipated out of the chiller to the environment. However, in a water-cooled chiller, the heat dissipation has to occur via a cooling tower. So, water-cooled chillers are slightly more complex chillers which are applied in specific applications. This is a kind of installation which we do in water-cooled and air-cooled chillers. So water-cooled chillers are usually mounted in the plant room area with a set of pumps and a cooling tower which is mounted at the rooftop, which dissipates the heat to the environment. However, air-cooled chillers, when you see, they are mounted on the rooftop itself, and you just have the pumping systems and everything linked at the rooftop. So these are 2 types of installations which are different to each other. These are some pictures of air-cooled and water-cooled. So you see that the condensers are in the shape of the coil in air-cooled chiller, and hence the heat can be dissipated to the environment directly. However, in the water-cooled chiller, you have shell and tube condensers which are then linked to the cooling tower. So what are the pros and cons of water-cooled and air-cooled chillers? We will first start with water-cooled chillers. The cons of water-cooled chillers are that these chillers are dependent on cooling tower and their efficiency. Although now we see that more efficient cooling towers have come with a lot of science getting developed, but yes, these chillers are completely dependent on cooling tower and quality of water. As the quality of water deteriorates, you can see a lot of scaling coming in the condenser, and hence the performance of the chiller getting deteriorated. So it just depends on the application where you want to put a water cooled chiller. Water cooled chillers are again more costly maybe to install because they have allied equipments attached to it like pumps, cooling towers, automatic tube cleaning systems which are attached to the condensers. And water cooled chillers also take up a lot of space in the building because of all the allied equipments which are attached to it. What are the pros of water cooled chillers? They are more efficient than air cooled chillers. You will see that the COP of water cooled chillers is always more than air cooled chillers, and they have better life and longevity. What are the cons of air-cooled chillers? In air-cooled chillers, they sit outside the buildings and their fans and compressors create noise in the surrounding areas which could be disturbing for the occupants living near this installation. Air-cooled chillers are typically do not have as long as service life as water-cooled chillers because they are more exposed to sun, rain, frost and all natural calamities. And air-cooled chillers can suffer from damage, blockages and recirculation issues. So whatever is in the environment of air, for example, if you have small particles of metals which are getting into the air because your installation is located near a factory or an industry, then this will actually cause damage to the fans which are installed with the air-cooled chillers. The pros of air-cooled chillers are that the air-cooled chillers cost less to install because they have less allied equipments associated with it. Air-cooled chillers require less space because they can just sit on the roof and they do not have to occupy your basements. Air-cooled chillers require less maintenance compared to water-cooled chillers because there is no condenser which is getting scaled and it is easier to wash the coils with water and they are quite maintenance free. And air-cooled chiller systems are much simpler to design and do not need another set of pumps for condensers. The pros of air-cooled chillers is, I think this is repeated. Okay, so we will come to the major components of chillers: compressor, evaporator, the controls and some of the options which I will describe. So these are some type of compressors which are available in the market for compression cycle: centrifugal, turbocore, recip, scroll, screw and magnetic levitation. These are the picture of centrifugal compressor. So what is a centrifugal compressor? The refrigerant flows through the suction line, hits into the center of the impeller where it will be directed by the blades, and these blades rotate and impart an angular velocity onto the particles of the refrigerant. So what you have to do is that you have to compress the refrigerant. Hence, this is the direction in which the compressor acts and the refrigerant gets compressed and then it is passed on to the condenser. This type of a compressor is basically a centrifugal compressor. Then we have a turbocore compressor which is also a family of centrifugal compressor. The only difference it has two stage of compression. So normally what you see different in a turbocore is that it has magnetic bearing and electronic motors which make it more efficient than centrifugal compressor. Then screw compressors, which are age-long technology which have been in the market and have been evolving since they came. They have two rotors which actually run with each other to compress the gas, and the compressed gas is then flowed to the condenser. Here we have scroll compressors. You can see the swirling of refrigerant inside the compressor. So in scroll compressor, applications are usually smaller applications which range to somewhere around 3 ton to about 150 ton, not more than that, because scroll compressors require a lot of maintenance, and these are use and throw kind of compressors, so not very reliable compressors. Hence, for larger applications, usually we use screw compressors or centrifugal compressors. Reciprocating compressors is a little bit old way of using a compression cycle. In reciprocating type of compressors, usually the refrigerant will pass through electrical motor to prove the cooling to the electrical coils and then head into the compression chamber. This is a very old type of compressor, so these are normally not used in market anymore. Maglev is the latest generation of compressors. These are normally called oil-free compressors because they do not have any oil inside these compressors, and they run on the basis of magnetic field which has been created inside the compressor. So we come to evaporators now. There are different type of evaporators. Specifically, when we talk about the way you want to evaporate inside your machine, and it just defines how efficient you want your machines to be. So the evaporators can be DX. In DX evaporators, normally the refrigerant is in the tube and the water is in the shell, so less refrigerant is used to evaporate the refrigerant which passes in the evaporator. And in flooded type of evaporators, the refrigerant is in the shell and the water is in the tube, so higher quantity of refrigerant is required in flooded range of evaporators. The evaporators again can be a single pass, two pass, three pass, on the basis of the design in which you want to react your refrigerant cycle. So I have already described this. Then again we have condensers. The condensers are usually flooded where the refrigerant is in the shell and the water is in the tube. Again, the condensers can be a single pass or a double pass condenser. We choose it in relation to the heat exchange area which is required to design that specific refrigerant cycle. So condensers again can be, as I have described, the air-cooled and a water-cooled system can be either shell and tube or the air-cooled condenser, the coil type condenser. So if it is a shell and tube condenser, it will be attached with the cooling tower to dissipate the heat to the environment. The first picture you see is a water-cooled condenser, and the second picture you see is an air-cooled condenser. The fourth and the major component of the compression cycle is the expansion valve. This controls how much refrigerant flows between the condenser and the evaporator. And it is very important to design this in a proper way because this helps us to also attain the maximum efficiency of the machine. There can be different type of expansion valves. One is thermostatic expansion valve, the other is electronic expansion valve. So here you see the picture of the thermostatic expansion valve. This was an older way of using the expansion valve where it used to work on the spring type basis. Now majorly we are using a lot of electronic expansion valves. This is the electronic expansion valve which senses is in accordance to the performance of the machine and opens the refrigerant flow in that context. We have also experienced in today's world that VFDs have become a, a feature which normally most of the installers want to install in the chillers, hence have become the fifth most important component of the refrigeration cycle or the chiller. So why do we use a variable frequency drive? Because it increases the efficiency of the chiller and also reduces the electrical usage of the complete installation. What are the advantages of a VFD chiller? It lowers the starting current, lowers DG requirement, increases the compressor life, precise current control at compressor input, has higher COP, lower power consumption at part loads, and higher power factor and safer in operation. So these are some certifications which are required to weigh how your chiller performs, because without the certifications, normally in today's world, people would not like to purchase the chillers. It's just like small ISO or ISI certified equipments which you purchase from the market. For chillers, basically AHRI and Eurovent are two certifying agencies which stamp that the allowable efficiency at the rate of the installation is in accordance to their guideline or not. And it is very important for you to understand these certifications and then purchase the chillers, because they provide a lot of weight to your purchase. This is a kind of test bench which is required to test the chillers in accordance to the requirement of the customers. The tonnage has been specified to you. So whether the chiller is delivering that tonnage in accordance to HRI certification is weighed on such a test bench. Some pictures of site installations. This is an air-cooled chiller which has been installed in a mall in Kolkata. A water-cooled chiller which has been installed in, I think, Vishesh Hospital, Indore. Again, a water-cooled chiller. So you see, all the water-cooled chillers are usually installed in the basement. Some images of centrifugal chillers, air-cooled chillers, and some scroll chillers. So chillers are usually applied to building air conditioning, commercial projects, hospitals, hospitality, marine, process, low temperature, plastic industry, industrial applications, then mining, shipping. So wherever there is a requirement of chilled water or chilled air, chillers are applied to all those applications. Now chillers can be applied to a comfort application like air conditioning, which you are experiencing here, or they're also applied in industrial applications like where chilled refrigerant is required at -50 temperature as well. So it just depends upon what application the chillers are to be designed, and hence the components are selected in that manner. So when we look at HVACR potential of India, the building construction is projected to increase rapidly, uh, and we see a growth rate of 6.6 CAGR, which is huge growth rate. When we have experienced that air conditioning today has become a necessity rather than luxury, and hence the requirement has increased in a prominent way. So you can see the comparison in 2005, the requirement in residential area was extremely little, about less than 15 million square meter, and it has risen to somewhere around 75 million square meter. This is just a map which shows how the chiller demand globally is increasing. With the rising temperatures, we have seen that the demand of chilling has increased over the years. These are some institutional frameworks which are to be kept in mind when you are designing the chillers, because we have to follow all these codes when we are selecting the components to make sure that we are mapping our chillers in all these codes. Normally, the refrigerants which are used are R12, 123. However, majorly in today's world, we are using R22, 134A, 404A. R22 is getting phased out. R410A, all these refrigerants are selected in accordance to their quotient, and these are also selected in a way that they are following the norms of green building. Again, when we talk about chillers, there is another technology which is today available, which is a VRV or a VRF technology. So we will quickly go through and look how it is a threat for chillers. When we see what is the difference between a VRV and a chiller, in a chiller we are chilling water. However, in a VRV or a VRF, we are chilling the refrigerant. So we see that the refrigerant is flowing in the entire building. It's not the, and when you compare it with the chiller, the chilled water is flowing in the entire building. So hence, when you talk about the safety hazards, when you see the refrigerant flowing inside the building and if it leaks, it is hazardous to the health. Again, when we talk about HRI and Eurovent, VRVs and VRFs are self-tested by the manufacturer and do not have any stamp of HRI or Eurovent. However, chillers normally follow all these norms. So we see future of chiller demand-wise in projects, retrofit projects, and construction of buildings. These are major futuristic approaches of chillers. Yes, chillers are also majorly required as a retrofit requirement. What do you mean by retrofit? Is just changing the old chiller with the new chiller. Whatever chiller has been installed maybe 20 years back was in accordance to the technology of that era. Today, more efficient chillers are available, and hence people would like to change these chillers to become a more energy efficient and a more green building norm kind of a installation. We have more smart buildings coming on the way, and hence future of chillers you see is more smart chillers, easy to control, with the control part of the chiller. New age flooded with less refrigerant charge with patent technology chillers are also available. Remote monitoring of chillers is possible now, and majorly all the green refrigerants can be applied on the chillers wherever it is required. So from service point of view, we have to see the refrigeration cycle in a way that what is going bad when we are servicing it. We have to keep in mind that we should not only have one approach while we are putting the chillers to service. We have to have the maximum 360-degree approach and see whether it is evaporator, condenser, expansion valve, even a filter dryer can be choked and is causing a major trouble to the chilling cycle. We have covered most of these things. So these are the major safeties which you have to observe while servicing a chiller. Low suction, high discharge pressure, high discharge temperature, antifreeze, motor winding alarm, input power loss, unsafe oil, chilled water flow switch alarm, phase balance or phase reversal. So majorly we have finished our session on the chillers. If you have any questions, I'm open to them. Yes. Yes, sir. It affects the type of compressor we use because the compression depends upon the viscosity of the refrigerant. So the components actually change when we are selecting the refrigerant. Uh, the sizing of the compressor changes, and also majorly when we talk about other components, the expansion valve, the tubes inside the evaporator, the surface area it has to expand or compress also changes. So yes, it largely depends upon the refrigerants. Yes.
In KEHEMS industries, which type of vapor absorption chiller you used?
No, sir, we
here?
don't manufacture vapor absorption. We only manufacture compression. So we only manufacture compression cycle, but we are manufacturing air-cooled, water-cooled, both the chillers. We also manufacture low-temperature chillers, and we also manufacture screw and scroll chillers.
So there is no vapor absorption chiller?
No, sir, no. Yes, yes.
Hello, ma'am. Have you tried to increase the efficiency of your chiller with waste heat recovery?
Yes, ma'am. So what we do is that when we have to use the waste heat, we put a small plate heat exchanger called de-superheater, which actually increases the efficiency of chiller. And via de-superheater, you can use small amount of hot water, which can be generated out of the waste heat which the chiller is producing. In this manner, we are making the chiller more efficient.
So you will be a competitor to the nearby company.
Yes, yes, sir.
And in without electricity, is there any gravity-driven chillers in market, or you're trying to do so?
In today's world, madam, there are some chillers or there are new technologies coming with solar. But without electricity, we have not experienced any chillers being produced in the market yet. At the moment, no. Yes.
It's my curiosity to know that.
Yes, yes.
Nice.
Thank you.
मैम HVAC सिस्टम को, मैम जो HVAC सिस्टम है वो डायरेक्टली कैसे अफेक्ट कर रहा है ग्लोबल वार्मिंग को?
कैसे अफेक्ट कर रहा है ग्लोबल वार्मिंग को? जब अपन खराब तरीके के रेफ्रिजरेंट यूज करते हैं और वो अगर हवा में डेसिपेट हो जाते हैं तो वह कहीं ना कहीं ओजोन लेयर को डिप्लीट करते हैं. इसलिए आपने देखा होगा कि जो गैसेस पहले यूज होती थी रेफ्रिजरेंट के लिए वो अब नहीं यूज हो रही हैं. फॉर एग्जाम्पल अपन R22 की बात करें तो उसका GWP लेवल बहुत हाई है और उसके कारण वो ओजोन डिप्लीशन को अफेक्ट करता है. अब आप मुझे पूछेंगे कि ये हवा रेफ्रिजरेंट बाहर कैसे जाता है? सो लीकेजेस से ये रेफ्रिजरेंट बाहर जाता ही है. अपन कितनी भी अच्छी मशीन मैन्युफैक्चर करें, कहीं ना कहीं क्योंकि वो मैकेनिक्स से रिलेटेड है, कहीं ना कहीं कुछ प्रॉब्लम आएगा और रेफ्रिजरेंट लीक होगा. रेफ्रिजरेंट अगर लीक होता है तो वो एनवायरनमेंट में ही जाता है और वो इसलिए ग्रीन हाउस इफेक्ट उसका खराब करता है.
Ma'am, according to you, which is the best refrigerant, which is environmental it is good for environment and cost efficient as well?
So the best refrigerant in today's world is CO2, carbon dioxide. But this is a very, very late refrigerant now come to the market. Systems are, manufactured with this. Yes, we are reaching there. Best refrigerant, CO2. Thank you everybody for patiently listening to me. Thank you so much.